Okay, we got a soil sample here. This is the good. We picked out the good, the bad, and the ugly. We're only going to show a good and an ugly. Okay? So for you Clint Eastwood fans, you'll get this. All right? So on this one, you've got a sample of this on your desk. Okay? And this is Ed's soil. And what we've got is we've got 3 years of this soil going from here to here to here. And you can see where we've moved this. We've increased the organic matter, we've rebalanced the mineral ratios, and these soils are doing way, way, way better. Okay, so as we go through this, we've got the good, the bad, and the ugly. And I want to borrow one of these so that we can kind of...
It's also...
Right here, what we're looking at is soil mineral balances. Calcium flocculates soil, it pushes things apart. Magnesium pulls them together. You don't want a loose soil because you can't hold the water, you can't hold structure, and you don't want a tight soil because then it becomes sticky, you can't get anything down into it, the roots can't grow out. So you want a balance. So on any of your total exchange capacities over 19, you want a balance of 69% calcium and 11% magnesium. That's the ratio that is the best for plant growth. Okay, so on this soil, we're at 30, so our ideal ratio is 69:11. Says that right underneath the plant. Okay, the next sample says the sample is 8.1 pH. Okay, a little above neutral, but looking at the calcium, magnesium, the potassium numbers, those are all alkaline minerals. They're causing the higher pH. Then you look at soil humus, okay, your humic content, 2.7%, all right? So we come down and we've got 76% calcium, almost 11% magnesium. So we're a touch high on the calcium, but dead spot on our magnesium. This soil will not be compacted. Your roots are going to go like wildfire out in this soil, okay? When you have a 20% magnesium soil, you are not going to have root growth and you're not going to have root penetration, and you're going to have such a small feeding area for your roots, you're going to run out of nutrition really quick. Okay? Magnesium tightens and restricts soils. It also pushes the air out and it pushes the water out so your microbes don't do well. Okay?
So what about on a soil where your magnesium is 5 or 7 on the low side?
Okay, then you have to add magnesium.
And the magnesium and the calcium is at 90 or 85 to 90.
That's a tough soil. Okay, you have to work on getting magnesium into that soil. Okay, those are tough ones. Okay, so.
And it takes time for them.
It does take time. It takes a long time. Ed's potassium here is 8.52% base saturation. This is a bodacious load of potassium. He's got a lot of potassium in this field.
So that's good.
Yeah, he's got 8% is like, so what we can do is go back here, go to the second page, over here and look at potassium. Okay? Okay, so when we get to the second page, we got potassium. What does 8% say? Very high. Okay, we are way, way up there. Almost excessive. Okay? Now, our sodium is at 3.5%. Now, for most crops, wheat, that's perfectly fine. If you're going to grow barley, you have to be 0.5% sodium. Barley likes sodium. Okay, so you're going to have a yield loss if you don't have quite as much salt out there. Okay?
On barley.
On barley.
Yeah, it is more salt.
It needs more salt. You're right. Exactly, Mike. Okay, so if we come down, we look at nitrogen. Okay, nitrogen on the good one is 73. Now, what that's coming from is the release of the nitrogen out of the active portion of the humus.
Is that 73 actual pounds?
It is. It is.
Okay.
Okay, now this isn't coming from organic matter. You have different stages of organic matter. Your top stages of organic matter, nitrogen is not available. When it gets down to the bottom stage, which is human, it is not available. That portion in the center, which is your active functional humus, is the only thing that's kicking out nitrogen. So that's what they test on here, is just the active portion of your humus. You could have 4% organic matter, but maybe only 2.5 or 3% is the functional part that kicks out nitrogen. Okay? So this isn't an organic matter reading, this is just humus. Okay? Then you look down here at sulfur. Okay, now sulfur is done in parts per million, and to get pounds you have to times it by 2. Okay? 46. So let's look at the sulfur thing. All right? Last page on the back. What's our sulfur number supposed to be, Peter? What does 46 say?
Very good.
Excellent.
Very good. Okay? That's a nice number. The ideal is 50 to 150. So we're just under that amount. Okay? So they say, hey, you could, to get a really, really good crop, you could put in a little bit more elemental sulfur and it'll break down. Now, let's go back and see where this sulfur was in 2015. And this would have been the 2014 test. Our sulfur was at 16. Then Ed moved it to 24. Now he's moved it to 46. So what are you doing, Ed? We're building up our sulfur content. What are you doing? How are you doing that?
Microbes,
Microbes, and we're putting out what?
1152. No, that sulfur 90. What's it called? Sulfur.
Elemental sulfur. So Ed's putting in a little bit of elemental sulfur every year, and now what we're doing is we're building this up to a better, healthier range, because these plants have to have sulfur. 3 of your most critical amino acids are all sulfur-based. They're not nitrogen-based. Okay, you have 22 amino acids. 19 of them are nitrogen-based. 3 very critical ones are only sulfur-based. Okay?
So Ken, if we take these soil tests and send them to the lab through the core, what's the name of the lab again?
Kinsey.
Egg guys.
Egg-wise.
Okay.
They don't go and do Pacific and break all the down.
No.
They do.
Well,
You got to specify that you want amino acid.
well, you can get different tests from different labs. What we had done is if you take an AgVise soil test, compare it to a Kinsey, they won't be close.
how about X-Source?
Why would they be close? Why should they?
Because they use different extracts.
He's got to be familiar with the lab.
Exactly. Everybody uses a different extract, and some guys will use 2 or 3 extracts to look at a dozen minerals. These guys use a different extract for every mineral. And so it takes forever. I mean, Kinsey is not quick, is it, Abe? It's not quick. You need 4 or 5 weeks.
Why?
Huh?
Ken?
Should be
Why
already-
isn't it quick?
Because he uses there's one lab, some soil samples come in from all over the world, and in their analysis, instead of doing a quick extraction, kind of shotgun approach to what is out there, they're taking every mineral and they're extracting it separately and accurately. So, and
And using a plant-based
natural,
which the other companies don't.
they're using
Chemical.
they use a chemical, and so a chemical extractant is going to be way stronger than a plant-based type extractant. And so what we're looking for is accuracy, because you're going to get this $50, $60 soil report, and you're going to go out and spend $50,000 based on this sucker. And so if this is wrong, what's it doing to your pocketbook? And so we've looked at a lot of different soil reports from a lot of different companies, and we couldn't get the plants to respond until we got here. Because we finally started looking at things accurately enough. We said, well, we don't need this, we don't need this. This is our problem. We put that in, and the plant goes, I feel a lot better. And so if we fix the problems, then we're not wasting money on fertilizer that isn't going to get utilized. Move on to our phosphate. Now, phosphorus. We have 2 phosphate readings. One's below 7.5 pH. The other one's above 7.5 pH. So, look at 576 pounds on this phosphate reading. One is at 750, the other one's at 350. They use the 750 on this one.
Yeah, the desired value was 750.
Okay, and they got 575. So where's 575 on this scale? Excellent. Okay, so they said right here, Ed is not buying any phosphate. And you can tell this is a manure field because you come down and you look at the potassium, it's through the roof. Okay, now let's look at the calcium. The desired is 8,200. There's 9,300. It's a little bit high, but there's no requirements. Magnesium, ideal is 877. It's 800. You know, it's spot on.
It's good.
Yep, his ratio should be 11% magnesium. He's 10.94. It's like home run. 9th inning, World Series, bases loaded, we win. Great number. Okay, no worries there. All right, we come down, potassium is a little bit high, and we're going to have more potassium than we can shake a stick at. They say on this one, Chilean nitrate, only because it's saltier than salt.
Doesn't it tie up if it's a little higher? Other nutrients, other micronutrients?
The salt won't. Salt is the first thing to leave your soil. Okay, so it won't tie up. But the problem is this is going to be, when they look at a barley field, when you have 3.5 or 0.35% base saturation sodium and you need 0.5, you're a little bit low. It's going to hurt barley. It won't hurt wheat, won't hurt corn, won't hurt alfalfa, but it will hurt barley. Okay, so anybody ever thrown rock salt out there?
40 rack.
Rock salt. You know?
Yes, we did this year quite a bit.
It's an odd practice, but it works. You got to get your sodium up.
We did 1,300 acres.
Okay. There's a way to get do this accurately. We're trying to find out what we have, what we don't have, because now we're trying to go back and look at the plant and it says, this is what I'm going to have. This is what I require to do my job. So we look very hard at these things. When we come down, let's go into the trace minerals. Now, every soil has deficiencies in trace minerals because these are ones we haven't put back.
You mean the boron, iron, manganese?
Yeah.
Copper, zinc.
Yep. And initially, when we tested Ed's soil, we tested molybdenum and cobalt. And we only do that once because once we know what those levels are, they're not going to change. Because we don't put out molybdenum and we don't put out cobalt as a dry soil additive. We put those in as a foliar because we do not want to spend the money to buy the dry products because cobalt sulfate is incredibly expensive. A ton of that will buy a half nice pickup. Okay? And you don't want to be putting that kind of stuff out in your soil. And so it's much easier to have it put into a foliar and spend $1.15 to fix your cobalt problem than buy cobalt sulfate.
We're just putting out a half an ounce per.
2 ounces a year on cobalt is all you need.
What, through liquid?
It's a liquid. It goes in as a foliar.
How about copper?
Copper, Ed's done it both ways, and once we get the copper going, I mean, we put a lot of trace minerals back in Ed's ground. And when you start looking at some of these, okay, let's go back and look at it historically. Okay? Okay, now, here's another interesting point. Let's go back up to phosphate. When we first started testing, it was 440. Then it went to 520. Now it went to 575. or 576. The phosphate is going up. Are you still applying phosphate to this field, Ed?
No.
Okay, so the microbes now are starting to alter some of the mineral ratios in this field. Okay, that's a good thing. Okay, because they're going to bring it into this better balance. When we look at boron, okay, we started at 0.98. We were at 1.5. We're 1.23. All right. So one year we put on 10 pounds of boron per acre. Okay, made a huge difference in what was out there. The last few years, what we've done is we've just been doing the foliar boron. So it's the plants are consuming it, it's dropping. Okay, when we go into iron, now iron isn't reliable on anybody's tests. So the rule of thumb here is if your plants are yellow, don't worry about it. If they're not yellowing, don't worry about your iron. If they're yellowing, we got an iron problem. Okay, but if not, don't worry about what the test says. Magnesium, okay, manganese, 62.3. Now when we get into our trace minerals, these are the guys here on the front, okay, very front of the sheet. Okay, turn it over, Peter. You got to go to the front.
Okay.
And it will tell you that your boron, the excellent range is between 1.5 and 2, which it's read in parts per million, so you've got 3 to 4 pounds of mineral in your soil. That's a great balance. Iron, for what it's worth, 200 parts per million is 400 pounds. Manganese, ideally, is 125 to 250. Okay, parts per million, which is 250 to 500 pounds. Copper, 5 to 10. So that's 10 to 20 pounds. 5 to 10 parts per million, 10 to 20 pounds. When you get your plants, your soils, to 5 parts per million copper, you will not have insect disease.
Give me that number again.
5. Okay.
Say that again, Ken.
Say that again, Ken.
Please.
Oh. Copper at 5 parts per million activates the immune system in your plant adequately, so you will not have insect and pathogen disease. Well, you can put out, there's so many pounds of copper you can put out a year in your soil. It's not toxic. Now the problem is in irrigated ground versus dry land ground, some of these minerals are expensive. Copper can run anywhere from $1.75 to $2.25 a pound depending on where you're buying it. And so you can't afford to put out 25 pounds of copper sulfate on dry land. You have to have a crop that will pay this back. So in dry land situations, we put it in as a foliar. And we can spend a few dollars on this mineral versus a lot of dollars in the soil. But you got to realize I'm not changing my soil number. I'm enabling my plant to function during that season, but I'm not fixing my soil.
How much copper can you put on before it gets toxic?
Maximum application per year. Come down here. Okay? Right underneath that, Abe, on your first page, maximum rate of application. Copper, 35 pounds of 25% copper sulfate. That's the most you can put on without whacking out your plants and messing up your biology. But you're way better off to put it in as a foliar because, one, on dry land you can't afford this. You put in 35 pounds of copper at even $2, that's 70 bucks an acre. Already blown your budget. You can't afford it. Okay, so what we have to do is, instead of putting it in the soil and going through the dilution factor, we put it in through the leaf and have it as a concentration factor. Yeah, you can keep your plants going through the foliar applications, but you're not fixing the soil. But some farming operations don't have the budgets to fix the soil. You can't spend this money on them.
Does some of your seed treats have boron with it?
Well, yeah, in our seed treatment, we have probably up to 75 or more minerals. They're in very small quantities, but you have to have certain minerals in higher quantities. So when we look at these are the very critical minerals that we have to have certain levels of. Okay? So when we sit down and we talk to you about this, we'll say, look, this is the most economical way to deal with boron. This is the most economical way to deal with manganese, copper, zinc, cobalt, molybdenum. And unless you got a high cash crop, you're looking at maintaining the plant through foliar applications, not trying to fix your soil. Kinsey is get the right adequate nutrition, but get the minerals in the right ratios so that you prevent all of these diseases and symptoms. If my copper's perfect and everything else is in the tank, not going to work. So we got to address a little bit of what we're really trying to do is just get a very accurate assessment of what's going to stop our plant from growing first. Okay, because on the bottom of a lot of these soil tests that we do, like on this one, they list the priority of minerals. Okay, what is going to be the most critical mineral that I have to look at buying? And I like this on the bottom of these soil reports because it tells you if you're going to allocate money, which will keep your plant going the longest and the best. What's my priority? So on this one, nitrogen is first, and then we switch into copper, zinc, sodium, and boron comes there towards the end. Iron, don't need iron. So you start looking at which mineral will shut my plant down first.